Example number 6. We want to find in part A the domain of the function negative log x minus 2. So we pay attention to the yellow part, x minus 2. The domain of the log function is greater than 0. So we set x minus 2 greater than 0 and solve for x. So the answer is from 2 to infinity. In part B, we want to wrap the function f of x. We already have the function ln of x. We either use way 1 or way 2 to get the wrap. So I already have the wrap in the pink color above. So let me copy the answer first. So we have here is 1, 0. We have here is e, which is 2.7, comma 1. And 1 over e. 1 over e is like 3 point something. Sorry, 0.3 something. It's a 0.4, comma negative 1. So we have this is the log function. And in front of the log we have a minus. So minus, we will reflect this graph with respect to the x-axis. The point 1, 0 is the image of himself. And then e, 1 will become e, negative 1. And the other point, we have 1 over e, positive 1. So we do the minus. So y equal minus ln of x. And then if you have f of x equal ln of x, and then you change the input to x minus 2, so you get ln of x minus 2. So the x minus 2 telling us that we need to move the graph to the right 2 steps. So to draw the graph easier, we will draw the line y axis, because y axis is like an asymptote. So we will draw the line, and that line will move to the x equal to 2. And we just go ahead and add 2 units to the x part. To label the new point, so this will be 3, 0. The first one we will have, the top one we have 1 over e, and we plus 2, 1. And in the bottom we have e plus 1, e plus 2, negative 1. In part C, we look at the graph and we determine the range and the vertical asymptote. So in part C, I want to do the domain array again and the range again. The domain we already found in part A is 2, infinity. And from the graph, we can see that the range is from negative infinity to positive infinity. The vertical asymptote is x equal to 2. Now in part D, we want to find the inverse. We write the function f of x again. Negative ln of x minus 2. Step number 1 to find the inverse that we learned in the section before is we need to write y as the f of x. The reason why we are doing that is because in step number 2, we will interchange the x and the y. And then in step number 3, we will solve for y. So we will multiply both sides by negative 1 And then we will use definition of the log to convert to the exponential equation. So the base that you do not see is the e. Then we write e to the negative x equal y minus 2. And then we add 2 for both sides to solve for y. So e to the negative x plus 2. Step number 4, the function f of x, we write in the notation, and that is the answer of f of inverse, e negative x plus 2. In part E, we want to find the domain and the range of the function f inverse. So we learned from section 6.2 that the idea of the inverse and the function is that the x and the y switching. It means that the domain and the range switching. So in part C, you remember I write down the domain is 2, infinity. And the range is from negative infinity to positive infinity. That is the function f of x. So now I want to find f inverse, the domain and the range. So what should I do? I just need to switch, right? So the range of the f inverse will equal to the domain of the function f. So 2, infinity. And the domain will be negative infinity to positive infinity. In part F, we want to wrap the F inverse. So after we wrap the F inverse, we can verify part E, that domain and the range. So I want to make the quick sketch for this. So the F, we learn from the section before that the graph of e to the x is look like this. So what all you need to do is you just input y equal e to the x and make the number negative 1, 0, and 1. So you got e to the negative 1, e to the power 0, which is 1, and e to the 1. So we have 0, 1, e to the 1 is like 2.7. And e to the negative 1 is 0.4. So we have this. And then the function f of x, f of inverse of x is e to the negative x. So we're going to do the negative first. We will reflect about the y-axis. So we should work y. Assume that we have f of x equal to e to the x. What if we change the input to the minus x? Then we got e to the negative x. So we can see that if you change the sign of the input, you will get reflection about the y-axis. So the point, let's call this is the point A, then the reflection will be this point. And the point 1, 0, 1 will be the same. And let's call this is like the point B. The image will be like this. And after that, what do we do next is that we will add 2 for the function, and add 2 means you will move 2 units up. When we move 2 units up, you pay attention to the line, the x-axis. That is the asymptote, right? So when you move up 2 units, that asymptote will move 2 units up also. And then you just copy the points. So from this graph, you can see that. So this is y equal to. The domain is all real number that we set in part E. And then the range is from 2 to infinity. In the book, they put the graph together, the function f, the f inverse, in the graph below. And you can see that they are symmetrical with respect to the line y equal to x.